Welcome back. This is Nick Agram. In this video, I will be discussing the binomial theorem. And the binomial theorem is very related to Pascal triangle. Before I go further to Pascal triangle, I will define the binomial theorem. It says parenthesis a plus b raised to n is equal to a sub n. As you can see now, I can put an example here. A plus b raised to 2, for example. We know that is a squared plus 2ab plus b squared. That means the n there is the 2 because our n here is 2. And then we have n minus 1. And then we have 1 there. So we have 2 minus 1, 1, and then we have this will become 2, and so on and so forth. Okay. Where n taken r is the binomial coefficient of a raised to n minus r, b raised to r. Okay, this is your r now. That is n minus r, that is 2 minus 1, and then we have our r here. That's 1. That's why. And r is 0 up to n. Okay? Because they can be equal. They can be equal. So if you have here n here now, or r also, as you can see. Okay. The general term, or r plus 1 term, is the binomial expansion t sub r plus 1 is equal to n taken r, a raised to n minus r, br. And the sum of a binomial is equal to the summation of n taken r, a raised to n minus r, b, r. We are going to use all of these three later in solving some examples. But as I've said, I'm going to give you some idea why the binomial theorem is a better way to remember the Pascal triangle. So for example, Pascal triangle is this one. 1, 1, 1, and then 1, 2, 1, and then 1, 3, 3, 1, and then 1, 4, 6, 4, 1. That's a Pascal triangle. And then 1, 5, 10, 10, 5, 1. Using this binomial theorem, I'm going to, for example, this is your 4, and then your 5. N here is equal, this is your n. Here is 0, 1, 2, 3, 4, and 5. Okay? So for example, let's say a plus b raised to 4, for example. Then we have a raised to 4 plus 4 taken 1, a raised to 3, b, plus 4 taken 2, a raised to 2, b raised to 2, plus, because it is n minus 2 now, and then our r is 2. That's why they are the same. It's always. And 1 there. Plus, I'm sorry, I already have plus there. 4 taken 3, and then we have a, b raised to 3, and then b raised to 4 there. And we know that 4 taken 1 is equal to 4 factorial divided by, if we use our binomial coefficient, n taken r is equal to n factorial divided by r factorial multiplied by n minus r in a parenthesis factorial. We're going to do that. Then we have 1 factorial times the difference 3 factorial. Then we have, if we expand that, we have 4 times 3 factorial divided by 3 factorial. Then we have 4. So this should be, if I'm going to use there with another pen, it should be a raised to 4 plus 4a raised to 3b. There we go. Okay. Another, we have 4 taken 2. 4 taken 2. We have 4 taken 2. Then we have 4 factorial. 2 factorial multiplied by the difference 2 factorial. Then we have 4 times 3 times 2 times 1 divided by 2 times 2. That's 4. 2 factorial is 2, 2 factorial is 2. And this will become 1. Then we have 6. There you go. So this will become plus 6a squared b squared. 4 taken 3. Then we have 4 factorial divided by 3 factorial multiplied by the difference 1 factorial. As you can see, this one and this one is equal. They have the same. 1 factorial there. So that is 4. So it should look like this, plus 4ab raised to 3. And we have our 4 there. And we have 1 there. Plus b raised to 4. I hope it's easier. Okay, let's try the 5. We have, I will write it here with another pen. We have a plus b raised to 5 according to this. So we have a, according to Pascal triangle, we have a raised to 5 plus 5 a raised to 4b plus 10a raised to 3b squared plus 10a raised to 2b raised to 3 plus 5a raised to 3 b raised to 4 plus b raised to 5. And for binomial theorem, then we have a raised to 5 plus 5 taken 1, a raised to 4b plus 5 taken 2. Oh, sorry, without the 5 taken 2, a raised to 3, b raised to 2 plus 5 taken 3, a raised to 2, b raised to 3 plus 5 taken 4, a raised to 3, b raised to 4 plus b raised to 5. Okay. And then we have 5 taken 1. That is equal to 5 factorial divided by 1 factorial multiplied by 4 factorial, the difference. And then we have 5 times 4 factorial divided by 4 factorial. There we go. Okay, and then 5 taken 2. We have 5 factorial divided by 2 factorial multiplied by the difference 3 factorial. Then we have 5 times 4 times 3 factorial divided by 2 multiplied by 3 factorial. And that is 1. And this is 2. Then we have 10. There you go. And then 5 taken 3. We have 5 factorial divided by 3 factorial multiplied by 2 factorial. As you can see, they are equal. There you go. And then we have 5 taken 4. We have 5 factorial. We have 1 factorial. 4 factorial multiplied by 1 factorial. And this one is equal to this one. That's what you got there. Okay? So Pascal triangle and the binomial theorem are very, very related. Okay? We're going to apply what we have learned in the binomial theorem. Write down the first 3 and last 2 terms of the expansion of 2x plus 1 divided by x parenthesis raised to 12. So our a is 2x and our b is 1 divided by x. So if we rewrite that, 2x plus 1 divided by x raised to 12 is equal to, we have the first term, we have a 2x raised to 12 plus 12 taken 1, and then we have 2x raised to n minus 1, that is 11, parenthesis there. B is 1 divided by x raised to 1 plus 12 taken 2. And then we have our 2x, this time is raised to 10, and then multiplied by 1 divided by x raised to 2 plus we have 12 taken 11. Our r now is 11. If we continue that, then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And now we have our a, that's 2x raised to 1 this time. So it's alright, the difference between them. And then 1 divided by x raised to 11 plus our b, 1 divided by x raised to 12. That's it. And I hope you learned something, and in my next video I will be discussing some examples regarding these two formulas, the general term and the sum of a binomial series. And thank you for watching, and see you there. Have a nice day.